So the first thing that we have here is the actual chemical reaction that you did. You were mixing your aluminum with potassium hydroxide, some sulfuric acid, water, and you are getting alum, which is a product of your reaction, and some hydrogen. The hydrogen, you saw the bubbles forming in your beaker under the fume hood. So the product is the crystals, and that's the alum. You have the formula right there. But we need the reaction for the stoichiometry of your reaction. You have that every 2 moles of aluminum, the 2, it's a coefficient that I have in yellow in front of Al. That's 2 moles of aluminum. For every 2 moles of aluminum that are reacting, you're getting 2 moles of your product, which is the alum. Okay? So that those coefficients we're going to use as conversion factors as part of your calculations. So you have the mass of your beaker, the mass of the beaker with the aluminum. You were supposed to have a mass of aluminum close to 1 gram. Now the mass of the aluminum will be the mass of your beaker, and aluminum minus the mass of the beaker, empty beaker. That will give you how much aluminum you're using. The moles of aluminum, so now I have here under calculations number 4, 5, 6, and number 10, which is the calculations that you need to complete for the table. So to find the moles of aluminum, you're using the molar mass of aluminum as a conversion factor. So in number 3, you have the mass of your aluminum, how much you're using. That number is in grams, so you need to convert your grams to moles to find out your number 4. So to find out how many moles of aluminum corresponds to that amount of aluminum that you have in grams, you have to divide by the molar mass of aluminum, which is this number right here. So the molar mass of aluminum is 26.98 grams in every mole. So your number 3 here, that it's a number in grams, which means that the unit grams is canceling out, and what you're getting right there is the moles of aluminum, which is the number that you need to put right there in number 4. The theoretical yield of product, okay? So this is how much product you can get in theory from your initial amount of aluminum. So to find that number 5 is where we need to use the stoichiometry of your reaction. So in number 4, what you have in number 4 is the moles of aluminum. So you're starting right here your calculation with the moles of aluminum. And now you need to convert moles of aluminum to moles of your product. So it's moles of a substance to moles of a different substance. In order for you to be able to do that, you need to use your coefficients from the reaction. In your reaction, 2 moles of product. To get 2 moles of product, you need 2 moles of aluminum. Since you're trying to calculate moles of product, that's the top part of your conversion factor, the one that you're trying to get, divided by 2 moles of aluminum, because that's what you have in number 4, moles of aluminum, and what you want to cancel out. So when you do your number that you have in number 4 times 2 divided by 2, that will give you right there the theoretical yield in moles of your product. Now number 6, it's what amount of product you can get. Again, the same thing, amount of product, but in a different unit. In number 5, you're finding amount of product that you can get with your initial amount of aluminum, but that's in moles. And now in number 6, you're finding the amount of product that you can get with your initial amount of aluminum, but in grams. So to find out grams, when you have moles of a substance and you want to find grams of the same substance, we're using the molar mass of that substance. So you have the moles of your product that you're calculating in number 5, and you want to convert those moles to grams. So we're multiplying here by the molar mass of your product, which is something close to 474 grams per mole. So your moles of product, which is what you have in number 5, times 474, grams per mole, that will give you the amount or your theoretical yield of product in grams, which is the number that you need right there in number 6. Number 7 is the mass of your watch glass, no paper. And number 8 is the mass of your watch glass and your product. So you have those numbers. So your mass of your product will be your number 8 minus number 7. And now to find out the percent yield, which is what we're trying to get since day 1 for this experiment, right? So the percent yield is the actual yield, which is your actual amount of product. And then you have your theoretical yield, which is in theory how much product you can get from your initial amount of aluminum. So your mass of product, which is your number 9, we're looking at here number 10 to find out the percent yield. So the mass of your product, what you have in number 9, divided by the number that you calculated in number 6, which is your theoretical yield in grams. You divide those two, your actual divided by the theoretical, times 100. That will give you the percent yield for the experiment.